Welcome to the Data Futures Lab channel. This is Shekhar and I am a data scientist. So in this particular session, we are going to develop a machine learning model for the movie recommendation system. So basically recommendation system works based on the different things. So one is it gives the interaction between the user and the atom or the product. So in this case, we are interacting with the movie. Okay, so whenever a user watch one kind of movie, so the same movie platform will provide you similar kind of the movies. So based on the attributes of the movie or the attributes of the product, that's recommendation system is provide the similar kind of the recommendation to the user based on the properties and the attributes or the features of that particular product. So in this case, movie, right? So let's get started. So we'll see how this recommendation system works for um, for movie recommendations, right? So let's first things is we have to import the required libraries here. So first thing is pandas, numpy the data manipulation libraries. The next one is the regex we are importing, that is for textual data manipulation. Then NLTK for again it's a textual data tokenization, then stop words, and for more functionalities, textual data manipulation functionalities, we are using a NLTK library also. Uh, Here we are suppressing the warnings, right? So next one, we have to load the data. You can see that the data is available here and we are using pd.read underscore CSV and displaying the data. So you can see that there is a lot of columns are there in this data set, but out of few are we are using for our use case. Okay. So I have already created one video on the exploratory data analysis on movie dataset. So you go there and watch that so that you will get the idea about what exactly it is. Okay. So in this particular case, what we are doing, so we are providing the title of the movie. And suppose if you user watch the Shashank Redemption, so based on the title, then genre, then director, and the actor, and the plot. So plot is basically a summary of the movie. So these things, when a user watch this movie, then this recommendation system will give the recommendation to the user with the similar kind of the movie. And this similarity is based on the genre, director, actor, and the plot. So how we can find out that similarity, because everything is a textual data, right? So we will see that in the next part of this particular session. Yes, so first we'll do some basic analysis. It's a 250 movie records are there with 38 columns. So you can list down the number of columns here so you can see, and the data type. So most of the columns are the string type, means you can see the objects, and rest of all are the floating values, right? So you need not worry about this because we are considering only a 5 columns from this data set. Now you can see that the movie is unique. Movies are 250 and the genre, if you can check, these are the genres. Okay. So 110 genres, different genres are there for these movies, right? Now you can see the plot is very important feature in this particular data set. So plot will give you the idea about the movie. So and based on that you can correlate those two movies. Now you can see that this description about the movie is given for the Shashank Redemption, and this is the description is given for the Godfather movie. So we are checking whether these two descriptions are similar to each other. Whether if they are similar, then we can say that if user watches Shashank Redemption, then we can provide the recommendation to the user with the Godfather, right? But how to check that similarity? And for that, we have to do some text pre-processing, and then we have to convert the textual data into a matrix or the numerical data. And for that, we have to use some the distance matrix. Okay, we'll check that what we can use here. Now, here you can see that we have considered the five columns: the title, genre, director, actors, and the plot. So these are the textual data, and these columns we are selecting and creating one more data frame. So you can see title, genre, director, actor, and the plot. So we'll start the text pre-processing on the plot data because plot column is having a more words. Okay. So first, what we'll do? So we will convert that text into a lowercase by using a string dot lower. So this is the string functions you must know. So in the first case, we have created a clean plot, means it is we are converting all the words into a lowercase. Second one, we have to remove the numbers and the punctuations, which is not important while creating the converting into a numbers, right? And so that we can reduce the dimensions or the features, right? Because in the NLP, natural language processing, or the textual data, each word is considered as one feature, right? So for that, what I am applying here, so I am applying a lambda function, and here using the regex dot sub, and whatever the data which is other than this, means numeric text, they are replaced with, substitute with the space. Otherwise, it is X, right? So I'm applying this logic here, and the data is ready, right? So we have removed the punctuations and the numbers. Now, next thing is we have to remove the extra space. So for that, I'm using the same thing, regex function, and these things here. Okay, now the clean data is available with us. Now, next thing is we have to tokenize this because we have to find out the only words which are having some meaning. Because some of the words like the, a, am, okay, I, these words are not having carrying any type of the meaning. So we have to remove that also. So for that we have to tokenize. Tokenization is nothing but we have to split the sentence into a small tokens, that is called as the words, we can say. It's simply by splitting this you can do that also. But here from the NLTK library, we are using a word tokenizer. Okay, and you can see that finally our data is divided into small chunks or tokens. Now you can see two: imprisoned, main, bonds. Okay. Now, next thing is main intention here is we have to remove the stop words. Now, what are the stop words? So you can see that from the nltk.corpus stop words English, you can just display the stop words. These are the stop words will not carry any meaning to the uh, while converting into a matrix. Okay. So we have, if these words are there, then we are removing that, right? And for that, I am writing here the for loop. Okay, so for sentence in the movie tokenize is means this one, and we are creating a temporary list here for word in the sentence. If word is not in stop words and length of the word is greater than or equal to 3, then that word is appended into a this list, and this list is finally appended into word list. So what finally we are getting is row wise we are getting a list of tokens. You can see this is for first row, this is for second row, like this. Okay, so these are the words are not these words are not having the stop words now, means the data is cleaned one. Now we are creating one more column as the clean tokenize, and is equal to word list because this is a list of list. So this will convert into column now. You can see. Okay, you can see. Yes, it's a clean text, clean tokenized data, right? Now, next one is clean tokenized. We want to see in the list. Okay, row-wise list you can see. Now, next one is we have to check the genre. So, genre is crime and drama, but again, we have to convert into a lowercase, and we have to convert into a list. And for that, I am using a split function here, dot split, just like here. So you will see we have converted this thing. But now again, this is the capitalized, but each word should be in lowercase. So we will apply that also, but before the actors, so these are the actors, and after using the this, we are creating the list of these actors, right? The same thing we are doing it for the directors. Okay. Now, what I'm doing, I'm converting, removing this space, extra space is available here, as well as removing the converting into a lower space, right? So what will happen, our the data which we are getting is a uniform data. Now you can see that whenever we apply these things here, okay, uh, this clean text function to uh, genre, because we are applying here the list comprehension for x in this, and clean text we are applying. So finally we are getting the data like this. You will see the Tom Robbins, Morgan Freeman. Okay, so now we have converted into this thing, the lowercase, and joined this name of the actors. Okay, same thing we have done here for the crime and drama. You can see, right? So now our data is ready. Here you can see the genre, director, actors, and this finally clean tokenize. Clean tokenize. These four we have to combine, right? Now what I will do, I will join this genre, director, actor, and the clean tokenize these columns and creating a single state sentence. And for that, I'm writing this for loop where it will consider the four call and create a sentence. Okay, so for I in the length of the movie data, so word here we are considering a empty string. For column in columns means here. So word is equal to word plus we have to join movie data. Call means this one I plus this, then second I, then third and fourth and fifth. So this is first, second, third, and fourth. These four columns are combined together and creating a word. So we are appending this into a sentence list. So finally, you will get this is the list of list again. So if you consider the first list of sentences, so you will see now we have combined this plot plus here is the what we can say genre, then here is the actors, and this is the director, so combined together. Okay, now our data is ready with uh, this thing. So finally we are getting a clean input. We are providing a clean input, so our we are using a clean input for our further processing, right? So I'm creating a new data frame here, considering only title and the clean input, and the data is look like this. Now, what we will do here, so we are checking the similarity among these movies, 250 movies. So Shashank Redemption having this text, and this text we are matching with the other text, 250 or 249 textual data of the movies, and we'll check the similarity among these. And for that, we have to do the word embedding technique or the feature extraction or the word embedding, we can say. So here I'm using TF-IDF and the Cout vectorizer. So you can use any one of these. From sklearn.featuresExtraction.txt, import the TF-IDF vectorizer and create the object of it, and then you have to fit and transform to the clean input means for this, and it will create a features. Okay, the feature are nothing but it's a matrix, it's a sparse matrix, right? So and this sparse matrix having the shape of, you can see, 250 by 3133. 3133 are nothing but the columns are nothing but the words basically of features. Means 3133 unique features are there, and likewise we have created this one, right? Now next one is these matrix we have to use here for checking the similarity. So from the sklearn dot matrix dot pairwise import the cosine similarity. So it will check the first row, second row. So it will check the similarity among these, and it will create again a similarity matrix. Okay, cosine similarity matrix. So here we have created the object of this, and the input is features comma features, means it will check the matrix of itself and checking how much they are closer to each other, means this row, this array is matching with the this array by how much. So that score is given, so you will see that here. So so 1 to 250. So the first one we know that um, it's a Shashank Redemption. So Shashank Redemption is matching with itself, so it is giving 1. Then second movie is Godfather. So Godfather is matching with uh, Shashank Redemption is by this much score. Then third movie is Godfather Part 2 is matching with this. So these two movies are similar because this is Godfather 1 and Godfather 2. Okay. But second one is this one. So it is matching with itself. So it's a 1. Okay. So you will get this kind of matrix. So you can see the shape of this is 250 cross 250, right? And when you extract this is for the Shashank Redemption, you will get it for the 250 movies. Okay, so here the one is for Shashank Redemption itself, so it's 100% matching. Then it is for Godfather, it is Godfather Part 2. Then third one is The Dark Knight, and 12 Angry Men is here, right? So like this similarity matrix in. Now for the Shashank Redemption, we want to find out the recommendations or the similar movies, and for that I'm creating here the index DF because that is very important. So based on the index, you can see the Shashank Redemption is 0, 1, 2. These are the indices of these movies, right? So I have created a separate data frame here, or the series we can say, and here is the we know the Shashank Redemption. So um, first we have to find out the top 5 movies which are similar to the Shashank Redemption, means we have to find out the top 5 score from this particular array, right? And for that I have to create I have to create a series like this. Okay, series is created, and I have to find out the top 5. So top 5, for that what I'll do, so I will use the sort function here, sort value, and ascending I'll do ascending is false, and I'm checking only the first 6 and dot index. So no, don't want index right now, but I want this one. So you will see there is an index, and that movie is Shashank Redemption itself, but we want to find out the similar movies for the Shashank Redemption. So these are the 5 movies which are similar to the Shashank Redemption because these are having a top 5 scores, cosine similarity matrix score, right? So the 13% for 7 index, but what is the movie at the 7th index? So we have to find out. So that is the Pulp Fiction. Then second movie is 18. We have to check. It's a 7. So these are the movies. But how to extract that? So for that, I'm using a logic here. I'm creating a list of indexes, and I'm running that indices, and for this index underscore df, and finding the movie, printing the movie. You can see Pulp Fiction 7 row, The Godfellas, Hatcher Dogtail. So these are the similar kind of the movies for Shashank Redemption based on the cosine matrix. So let's build a recommendation system. So what I'll do, I'm putting this all the code into a one. So here I'm finding so when you insert the movie name, so it will create the index of that particular movie. And based on that index, it will sort that score. Okay. Out of that, we are creating the list of top five scores and their indices, and these indices we are iterating into that data frame and finding the top five movies, and it will finally give you the list of these five movies, right? So this logic we have used, but uh, the same we have to convert that logic into a functions because it should be a reusable. So I have created written one function is recommendation system. When you provide the movie title directly, you'll get the list of recommended movies. So I am running this, and for the Dark Knight Rises, you will see the recommendations are Dark Knight, Inception, Batman Begins, The Lord of Rings. Then Shashank Redemption, already we have seen one more time, we will see for using this. Pulp Fiction, Seven, Drove, Godfellas, Heshi, and finally it's Avenger, Guardian of Galaxy, Aliens, right? This part is important. Before that, this text data conversion, that is the TF-IDF. This is one part, and second one is the cosine matrix. These are the important parameters in this particular case while converting the into textual data into vectors or the matrices. Okay, one more thing is very important, that is called as the text pre-processing, that we have done here by using NLTK, regex, then string functionalities, right? And that is very important part. So you can build your own models. So if you have any questions, you can just comment it in the uh, comment it out, and I am providing the dataset list in the description box. You go and check, build your own models, right? Thanks for watching. Thank you. Thanks a lot.